Assalamu alaikum. Well, guys, this is another question, and this is from May June 2022, paper 1 2, right? Physics paper 1 2. A child of mass 20 kg stands on a rough surface of a sledge of a mass 40 kg. The sledge can slide on a horizontal frictionless surface. One end of the rope is attached to the sledge. The rope passes around a fixed frictionless pole, and the other end of the rope is held by the child as shown. The rope is horizontal. The child pulls on the rope with a horizontal force of 12 Newton. This causes the child and the sledge to move with an equal acceleration towards the pole. What is the frictional force between the child and the sledge? And four options are given. Well, first of all, you need to understand one thing over here. There is a relative situation between the child and the sledge for this type of motion. The child and the sledge should be therefore treated as two separate objects but having a same acceleration, and then we will apply F is equals to ma separately for both of them. All right, now let's say consider the child first, and I've just made an arrows for the forces, and I have also mentioned the feet of child because the child is standing on the sledge. Okay, well, if and I just made a separator here, child and sledge. Now child is pulling the rope. Let's see, I have made an arrow. Okay, and at the same time obviously he is trying to stand on the sledge, right? So if he's pulling the rope in this direction, it should not go backward. The feet must have a friction here, and this is the friction between the feet and the sledge, which is we are looking for. So if I am using a F net, a resultant force acting on a child equals to child's mass, which is 20, yes, multiply by the acceleration, then the F net would be 12 minus frictional force as 20a, make it equation number 1. Now come to the sledge individually. Consider the sledge only. I'm just this here. This is the point where the rope is attached with the sledge. Since child is pulling the rope in this direction, so the rope will pull the sledge in the direction towards right. Again, remember, the child is standing on the sledge. The whole sledge is trying to move in this purple arrow, in the direction of this violet arrow. So now child, in order not to slip on the floor of the sledge, the friction must come also in the same direction. Therefore, on the sledge, the two forces acting are 12 Newton plus the force of friction. In fact, the F net would be, first of all, would be m into a. The body is sledge, therefore the mass is 40 multiplied by a, and the resultant force is actually 12 plus F equals to 40a. Make it equation number 2. Now let's change the color, and adding 1 and 2 together, right? 12 minus F is equals to 20a, sorry, and this is the first equation. 12 plus F is equals to 40a. I am adding the equation. I'm getting 24 equals to 60a, and a is equals to 24 by 60. 24 by 60, I am getting 0.4 ms minus 2. This is the acceleration. Now substitute acceleration in any one of the equation. All right, any equation you can say. So 12 minus F is equals to 20 into 0.4, and I am now working for 20 into 4 is going to be 8. Force of friction is coming 4.0 Newton. So the option is A. It's comparatively, like a little difficult in a sense that there is a relative situation between two objects, and we have to solve accordingly. All right, thank you very much.